Let's walk through programming Intro 7 in your packet. Intro 7 is a holes block that's going to be center drilled, drilled, and tapped. Let's begin by setting up our stock geometry, but first we need to create a brand new program for this particular part. We're going to Program Manager from the input screen. We're going to select New and Conversational Program. That creates a new program in the list. Next, we want to set up our stock geometry. We go to the input screen, Part Setup, More, Stock Geometry. We want to manually size our stock, and we set up some stock for this part. The x-axis or x-length of the part is 1.368. The y is 1.86. And this part is 1.35 thick in the Z. Now we need some tools. Let's go back to the input screen, Tool Review, Tool Setup, and let's begin to create the tool list. Now we have three tools in this list. The first one is a center drill, so I'm going to select center drill from the pull-down menu. And because a center drill has multiple steps and diameters to it, I know that I need to go to the More and Advanced Tool Settings tab so I can enter in the information to accurately describe my center drill. It's an 1/8 inch center drill. Make the tip diameter 50 thousandths. The shank diameter is the same. Overall length is fine. We'll make this tip and edge angles both 60 degrees, and we'll make that tip 50 thousandths long. I hit the exit button to go back to my main screen. Now I can go to Tool 2, which is a drill. It's a 5/16 drill, so 0.312. Set some cooling condition, speeds and feeds. And I just realized I did not do that for my center drill, so let's go back and do that at this time. Back to my drill. And for the drill, I also want to go to my advanced tool settings because I would like to set up this drill angle here of 118 degrees. I like my graphics to be as accurate as possible, so I want to take the time to set my tools up accurately. And that only leaves me with Tool 3, which is a tap. Now I know this is a 3/8/16 tap, and I know the diameter is 3/8 and the threads per inch is 16. I can simply type those into the two fields, or I can select this little icon, which allows me to search through all the tap sizes available, find the 3/8/16, and it will fill that information in for me. I'm going to tap this at 1000 RPM using primary coolant. Now I have all of my tools created, so now it's time to write the program. Back to my input screen, select Part Programming. This is going to be a holes block, so I select the holes menu. And I start to fill out the operations. First, I want a center drill. That's a drilling operation, and it's using a center drill. I'm going to wrap it to 100 thousandths above, and let's go down 1/8 of an inch using Tool 1, and the rest filled in for me. Now notice that the button here says Next Hole Operation. If the cursor was up here on the block number, I would have Next Block. It's important to remember that when we create a holes block, that all the processes in that block are under the sub-block section or hole operations. So I want to make sure operation is selected, and then I'm going to hit the next hole operation button. The next thing I want to do is drill the 5/16 hole, so that's a drilling operation. It's using a drill, and I just need to give it a depth here. We're tapping to a 3/4 inch depth, so we want to drill a little further. Let's go 1 inch to be safe. Using Tool 2, speeds and feeds are there, and I think I want to peck this at maybe 1/4 of an inch per peck. Now I have two settings for pecking. I can have standard, which is going to wrap it up out of the hole between pecks, or chip breaker, which is simply going to pause at each peck level to break the chip. I also have the setting to how far above the Z start the tool will move between pecks. And I want to move that maybe 50 thousandths. I don't see any reason to go all the way up to the 0.1. Go back to my operations, and I need to now program my tap. Tapping operation, and I'm going to use rigid tapping because it's an option that is available to me. Let's go down 3/4 of an inch as the print calls using tool 3. And you see that when I do use rigid tapping, I am able to peck that tap. No reason in this case, but if this was a very large tap, or if this was harder material, I might want to peck that. In this case, I don't. Now you can see if we go to the review screen here, we have one holes block with all of the processes that we're going to be doing: center drilling, drilling, and tapping. The one thing that is still missing is the where. We have programmed the what we're going to do. We have not told the machine yet where to do it. So as another hole operation, right after the tap, we're going to select locations. In this case, the print gives me an X and Y location for the hole. The other option could have been rotary locations. Bolt circle. Bolt circle would have given me the ability to tell it how many holes were in the bolt circle, where the center, and what's the radius. But in this case, as I said, we're using locations. Now there's only one. The X is 0.68 and the Y is minus 0.93. So I'm ready to draw. I hit the draw button. I'm going to go to my graphic settings and show all, and I want to draw this. Now as you can see, that my hole does not appear on my solid. Prior to this print, everything we have done so far in Intro 1 through Intro 5 has been using the bottom left corner as our 0 point. You see here that we're programming from the upper right corner, upper left corner of the part. So if you look at the way that this graphics is displayed, what is wrong? Is my hole in the wrong location, or is my stock in the wrong location? Well, in this case, I can tell by the little Cartesian coordinate in the bottom left corner of my solid model that it's my stock that's in the wrong place. So the way that I get around that is I go back to my input screen, I go to Part Setup, More, and Stock Geometry, and I want to use these X, Y, and Z reference positions. I'm going to move my stock negative 1.86. That's the same value as the length of my part in the y-axis. What this will do is move that solid model into position, so when I draw it now, it puts it in the correct location. And here we see there's our hole. Now if I were to turn this on its side, change it from transparent to, or from opaque to transparent, and redraw, you'll get to see that I took the time to set that center, or that drill up with an angle on it, and we can see that now in the part itself.